Hello everyone and welcome. My name is Jukka Haho and it's a pleasure to be your host today. We are continuing our webinar series with an engineering team and today's topic is floor truss engineering. I'm excited to introduce our expert and speaker today, Yao Xi. Yao, would you like to say a few words about yourself?
Australia, and also the managing director of our Chinese office. I've been working with Vertex for 10 years.
Thank you, Yao. Before we begin, a couple of practical notes. Feel free to submit your questions and comments using the question section in your webinar interface. We will answer them after the presentation. This webinar is being recorded and the recording will be published on our YouTube channel. So it will be found from there later on. Yao, the floor is yours.
Okay, thank you, Jukka. Floor trusses, some people also call them webbed floors, are one of the most common floor systems in leggage steel constructions. In fact, I think they are probably the most common one. They come with a lot of benefits. They are very flexible, so you can design different floor depths. You can even make them from the same profiles you use for wall frames, which means you don't need to buy another machine just for your floor system. And because of the open web design, like plumbers and electricians can run pipes and cables through easily without drilling extra holes. Now, as a detailer, once you design a floor truss system, you need to know if it's strong enough for the application. That's where floor truss engineering comes in. So in this webinar, I will show you step by step how to do floor truss engineering in Vertex BD. We will also look at how to export engineering results, and I will share a few simple ways to make floor trusses stronger when needed. And if you have any questions while watching, just type them in the question box like Jukka just mentioned. So we will go through them at the end of the session. All right, let's get started.
Hello everyone. In this demo, I'm going to walk you through the floor truss engineering process in Vertex BD. Let's start by switching over to the 2D drawing and opening the floor truss layout. This is a real project that has been built, and from the architectural plan, we know there are some wet areas with step downs. And these step downs have already been detailed in both the architectural model and framing models. So, like usually, engineer will require a bit of extra live load or dead load in these spots. So that's what we're going to add first. To make things easier to see, I will hide all the trusses and truss labels and the main floor areas and just leave these step down areas visible. Now we can head over to the engineering tab, and from here we can click the area load. For this project, I know the extra area load we should apply is 0.5 kilonewton per square meter. So to add the load, we can select the floor area and draw a closed rectangle around the area and confirm. So see the load is added. Or we can just connect the opposite corners of the rectangular areas and click OK, like this. Now all the loads have been added, and let's bring back all the trusses so we can keep working. Now let's try run the engineering function by click this members and trusses button here. So in Vertex BD, the truss engineering function itself is not only checking the trusses, it's also checking if the model is properly detailed or not. And I think here, the function itself, it will pop up some arrows here. It will stop us from running the truss engineering. Let's jump into 3D model and open the warnings and errors list. So we can click each of the arrows listed here, and in the 3D model, the problematic area will be highlighted as well. So we can see the arrow says this structures doesn't have enough support, and we can use this bearing structure function to check the support of each structure. For example, if we highlight this truss, we can see there is a wall panel being highlighted underneath, the purple color wall panel. That's a support, but that truss only have one support, and these trusses don't even have any support. And a truss should at least have like 2 supports to be able to run the engineering. So now that we know we need to add support to the trusses and there are already beams in position, we just need to connect them to the trusses. And first we can hide all the wall panel from the model tree so we can see the trusses clearly. To connect the floor trusses to the beam, the most commonly used joint would be the one in our truss connection joint library, which can be found in the folder down here. And the most commonly used one would be this floor truss hangers. Just double click this one and select the beam, and following the instruction of the software to select the bottom chord of each floor trusses that's connecting to this beam one by one. So after we're done with selecting this bottom chords, we just need to right click and click OK, and click OK again just to use the default hangers. So and we will repeat the same process for the other beams. Click and right click, OK, and OK again. And over here, noticing that I'm only creating this kind of truss hanger connections between the trusses and the opening side of the beam, because I'm planning to use another type of joints on the other side of the beam. Now if we go back to the connection detail library and go to the trusses folder, and down here we actually have a specially designed function to connect the trusses, particularly the floor trusses, to the webs of the beams. And this function is actually pretty easy to use. Just double click and we can just select one truss and Control A, press Control A to select all the trusses, and we can keep holding our control to individually select all the beams, or we can just press Control A, which will select all the structure steels. But because we don't want to add these structure columns into the selection, we can actually use this search function here. Just simply input beam and press OK, and the software will pick all the beams for us, and click OK. And depends on what size of beam you are using. We can have different connection parameters here. And we remove the previously added connection, and we can see the connection between the beams of the webs of the beam and the trusses have been added. And now we can go to this bearings of structures again, this function, to verify if all the beams have been recognized as the supports of the trusses. As you can see here, every time we highlight a truss, the connecting beam will be highlighted as well. That means these are the supports of the trusses already. And if we go here, we can see there's only one beam supporting the truss, and on the other side, there's actually a gap between the trusses and the wall underneath. But to fix this issue, we can't just raise a top plate of the wall frame. We actually need to go to the architecture model to see that if there's a gap between the truss and the wall top, because the truss engineering function is actually checking the bearing of the walls from the architectural model. So we need to raise the top of the wall and the top of the wall panel to the bottom of the floor, and we can go back to the framing model and generate the frames again, and to that way the gap should be eliminated. Now we can just use this bearing structure function again, just to show you this wall has been recognized as a support now. Okay, let's keep going. There are also trusses that are being supported by other trusses, like this one here. In this kind of situation, we can actually use this direct screw connection. We just select the function and select all the connecting trusses and press OK. So the software will add the joints, screw pattern joints between these trusses automatically. See these tiny red lines are the connections. And now if we just test around the truss engineering function again, see if there's anything we missed. Now the software is checking the model in the background to see if we have added support for all the trusses. Okay, clearly we missed something. If we open this arrow messages and highlight all the messages, we can see that these trusses are not fully supported yet. And if we jump to the 3D model again, and remember it's this area. Yep, yeah, we can see these truss and the connecting 3 trusses do not have connections. Again, we can use this truss hanger function here. Or the direct screw, it's just up to you. And the other one, I think it's around somewhere down here. Yep. Here, I can see it's already connected to that side, so it's missing connection on this side. Again, we use this hanger function, truss hanger function, to create this function, to create these joints. And we still have, I think, 2 more to fix. So the last 2 trusses are, so these 2. Okay, we can see actually these 2 trusses are like connecting to the, I think the column in between them. It's supported by a beam on one side, and it's connecting to the column on the other side. And we need to create a connection between the trusses and column, which we also have a special connection for this kind of situation. Just select all the trusses, confirm, and pick the column, confirm again. Just input the parameters here. We don't want to add this hole. And yep, so now press OK and the joint will be created. I think we have now added all the necessary connections for the model. And we can test around these members and trusses again. Now everything should work. Okay, when this window pops up, it usually means the model has been checked and it's now engineering ready. And here we always have this optimized connection between truss members selected, so the software will optimize the screw quantities during the engineering process. And the other, most of the other parameters are from the Australian standard. For example, this live load 1.5, but the dead load here is depending on what kind of floor finish you are using. And for this project, it's 1.0. This is given by the engineer. And this deflection, maximum deflection here, it should be 12, which is given in the Australian standard 1170. And for the buckling settings, the effective length of top chords and bottom chords, you can consult your engineer. But for this project, we use the width of the floorboard and the width of the ceiling board as the effective length for the top chord and bottom chord. And after we set all the parameters, we just click OK and select all the trusses and right click and click OK again. So now the truss engineering process starts. Oh, I should say the engineering calculation process starts. So the calculation process itself normally take, I think, 3 to 4 minutes for a project size like this. But I think I will just speed up the video a little bit so we can see the results quickly. Okay, after the engineering calculation is done, a window will be pop up on the left side of the window, which shows us some warnings and errors. These warnings are typically can be ignored, but the error messages is something we need to address. And after we close the window, the color of the truss labels will be changed. The green ones are the ones past the engineering calculation, and the red ones are the ones failed. And we can select the red ones and right-click, go to the truss engineering, which will open up this single truss engineering model to check what happened to the failed ones. And we can see actually for this one, the reason why it failed is because we actually missed a connection between this beam and the truss. So we just found the connection details, and we can keep using these floor truss hangers. Click OK, OK again, and we can just test, click this solve to run the engineering again, just for this single truss. Yep, now it passed, and as you can see, because we have modified the structure, all the colors of all the label colors turns into orange, that means the structure have been modified after they passed the engineering. So we need to actually run the truss engineering again on all these trusses to make sure they passed. Okay. Now if we close this window, we can see all the labels turned into green, which means all the trusses have passed the truss engineering calculation. And now we just need to export the results. The most common one is this truss engineering drawings, which you just need to click the truss and select the truss, click OK, select the template, and click OK again. So the software will generate a truss engineering drawing, which includes all the calculation results and loading conditions. And we can just use this one to give you an example again. And yeah, if we go to the tables here, it shows the extreme reactions, the load conditions. This is the user added load, which is that extra area load we have added to the wet areas. And here in this table, it shows all the calculation results of each member. And we can click this trusses icon and select all the trusses and click OK again. Then it will generate the truss engineering results for all the trusses. And another type of results is summary capacity summary results, which can be generated by select the truss and directly go to capacity summary results. This is a table-based results which some engineer will require. So it has very detailed calculation results of each truss listed in this table. And if you wanted to generate all the summary report for all the trusses, again, just pick all the trusses and right click and go to summary capacity summary results. This is a long process. It will take quite a few time if you have a lot of trusses in the project. But once generated, it will be a big document which includes all the calculation results of the trusses that have been selected. Okay. And to find all these drawings and results again, you can navigate to this document browser from the bottom left corner. And the drawings are under this structure drawing and engineering structure drawing, actually engineering. And the reports are under this reports design and summaries. Because I think the floor depth of this project is 400 mils. So with this depth, it's pretty easy to pass the floor truss engineering. So I think let's just add some crazy load to some position and try to fail some truss on purpose, so we can demonstrate how to strengthen some trusses when it's failed in the engineering. Okay, let's go to this engineering tab and click line load, and we can use 5 Newton per meter live load and dead load, and we can add it to, for example, between these two trusses. Yeah, actually, I think I will just add this line load between this the other two trusses. Yeah, because these two others shares the same label, which would be quicker to engineer again. So let's run the truss engineering again, just on these two trusses. Here we click OK, pick this truss, and click OK again. Okay, this is the real speed. Okay, down. If we close this window, we can see these two labels turns into green. Oh, sorry, red. That means they failed the truss engineering. And let's go to this truss engineering window again to check. Okay, as you can see, a line load is added here, and the pink ball over there shows where it fails. And to strengthen this, we can try a different method. First, we can just use a boxed piece. Now we add a box piece just to cover this area and solve again. Yep, I think it passed. Okay, sometimes your machine may not be able to produce this kind of boxable sections, so we might need to look into other options. I think in this kind of situation, we can always try to use the side reinforcement as well. I will just solve again just to show it failed here. And if we go to connection details and from this truss holder again, there's a side reinforcement. And we pick the piece which we want to add side reinforcement to, and we pick the length to show where we want the side reinforcement to be added. So this is a side reinforcement, and if we click solve again, I think it will pass as well. Yep, the label turns green. That means it passed the engineering. So side reinforcement also works, and yeah, we can also try to actually, I think we can replace the, we can just increase the thickness of the base material actually. Currently we're using 0.75, and yeah, if we select all the members of this truss and from this corner, we can just pick change the material thickness to 0.95 and click solve again. Okay, the label turns green and the design passed. And from the bottom, we can actually see the capacity now reduced to 76.2%, which means actually increasing the material thickness from 0.75 to 0.95. In this case, actually, I think increase the capacity of the truss by 20% or more. Yep. Okay, that concludes today's demonstration. And thank you very much for your attention, and I'm happy to answer your questions now.
There was the one question related to when we were using this reinforcement, that would it be possible to adjust the amount of screws? I think that's always possible.
Yeah. All right. So we got a question regarding what type of join connection can be used between the top and bottom course to the webs. So basically now, currently we only have screws. We can also, so in the engineering, if you can see here, it has like two red cross here. That means after the engineering, the software thinks you need two screws here for these joints. So this is a table-based calculation. So we can customize, if you have your capacity of any sort of joints, like a bolt or rabbit, we can customize that into our software. So in the engineering, it will use those capacity for engineering calculation. But by default, we only have screws. And there is a question regarding US standard. Sorry, we don't support US standard at the moment. We only, the standards we support listed here, including Australian standard, Eurocode, and Chinese standard. There's a question regarding the connection between trusses. I'm not sure if you're asking like this. If you can see this red box, that's the screw pattern, but this is only like a joint between these trusses to tell the software that this truss is being supported by this one. It doesn't, it's not engineered during the engineering process. And you have different options in the software. Like you can also use these brackets, and I think there are more in the drawing library and this component. Eurocode checks. Sorry. Yeah, I just wanted to mention this this webinar is designed for detailers. So if you have some engineering questions regarding how the software is, running in the background to come up with all these results, please contact us, and we can give you a more detailed explanation. There's a question regarding a cantilever bus. I'm not sure which one you mentioned. And it's on the cantilever. Can I use this software to analyze design and structure, including wind forces, and could it be used on system? All right. My colleague David, he just had a webinar, I think, a few weeks ago, talking about roof truss engineering. In that webinar, he talked about how to add wind load to the roof. And that recording of that video webinar is already in our YouTube channel. You are more than welcome to check that video. And we will have another webinar regarding the wall wind brace design later, which will be hosted by my colleague Paul. He will talk about the wind brace design. Yeah, that's the topic of another webinar. I think there's just one more question. Do we have to run wind load for engineering floor trusses? No, we don't. We don't have to run wind load for floor trusses. It's if you watch the video on our YouTube channel, which David talked about roof truss engineering, for roof trusses, you have to apply the internal pressure area and wind load to the roof. But for floor, you don't have to add wind load. Yeah, there's a question asking how many meters can this floor truss handle in one floor house. It really depends on the design, so I can't give you a direct answer on that. You have to engineer, like test it. Okay, I will give you the presenter.
Thank you all for your active participation and the great questions. I hope this webinar has provided you with new tools and inspiration for your future designs and projects. And you might have more questions, so we are more than happy if you contact our Vertex BD sales teams and find experts from there to answer your detailed questions. Stay tuned as we will have soon another interesting engineering topic for you, as you see. Again, thanks again, and have a great rest of your day. Goodbye.
Thank you very much.